Very good afternoon, students. Okay, let's settle down. Today, Zoom is doing some issues. Let's see if we have our basic functionality going on. Anyway, very good afternoon and a very warm welcome, students, to your first session of the most interesting topic that you will ever come across when you're learning aviation or when you're learning anything about aircrafts. I won't just say technical. I won't just say technical general. I would say this is the subject where you actually learn how to master the art of flight, not just handling of the aircraft, but the actual theory of flight or the actual mechanics of flight, as we call them. So let's get our thinking hats on right now. Okay. I'm going to ask you a few questions. Let's see what you have to say. We have Harsh, Muskan, Prerit, Nakul, Jason, and Om. Very nice. I'm very happy with your performances, by the way, in the next class. Students who have not yet given those tests up to our segment 1.3, ensure you're well prepped. Now, did you see, even if the questions are repeated and the options are repeated, it's very easy for you to mark the same questions which you had confusions. This is why all students just prefer to, not study much but solve question papers. I was very happy to see how you have performed irrespective of that. I wanted to shuffle the options again, but I thought let's see how much they are keen on marking the correct answer, thinking and doing it. So I hope everybody has done it thoughtfully. Uh, I'll be giving you such surprise tests for all segments involved so far, as and when. And I will be checking your knowledge, and I would be expecting you all to give me 10%, that is 100%. So in the second test, surprise test, apart from one student, everybody else got 100%. Congratulations. And before that, I could see somebody who had scored second or third was able to score first and second on test two. Somebody who had scored first or second was almost in the top three. So I'm liking this, what you're doing these days. And I can see everybody is improving and growing. See, our mind is tricking us in understanding certain questions. We need not be tricked by our minds. Okay. Let's come back and let's talk about this subject that we have, or this topic that we have. Now, it's called principles of flight. It can also be called aerodynamics. It can be called mechanics of flight, and anything and everything that will come across with respect to the definition of this subject. Now, this subject is a vital subject with respect to the design of an aircraft, and that design of an aircraft with respect to this is done by aeronautical engineers. The same concepts that we have to learn as pilots are the same concepts that our engineers are learning or studying. It's just that they have a lot of math. Here, we won't have that much of math, hardly 5 to 10% of the math. Irrespective of whether we have the math or we don't have the math, the concepts, the theory, the laws, the fundamentals, they all are the same. For us, it becomes a little more easier, but you can understand this to be level 1, 2, 3, and then level 4, 5, 6 could go into specialization with respect to the engineering, which we don't have to do. We have to just study this with respect to what students? With respect to our CPL requirements and ATPL requirements. Understand 70 to 80% of CPL and ATPL is the same. CPL has just certain extra added elements or topics for us to learn. Now, I want to know, okay, we all can see the screen. I have an aircraft, okay, conventional aircraft, with respect to which I have a tail plane and I have a main plane. Okay. Now tell me, what are the important functions of this aircraft of different parts. One by one, you'll name a part and you will name a function. Everybody will start thinking and try to give me answers. Quick, 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 quick. Go ahead. My channel is open.
Sir, I would like to tell something about the fuselage.
Mm-hmm.
So, sir, the
Mm-hmm.
fuselage is the main structure. It carries the payload, crew, and it is the effective position to operate the aircraft. Also, it has a space for controls, equipments, and everything. And with respect to fuselage, sir, it transfer loads to and from the fin, the landing gears, main planes, tail planes, and some configurations of the aircraft and the power plants that are engines. Victor Tango Mike Sierra Lima.
Very good, Muskan. Very few people can actually give me all functions. And I'm very happy that you're giving me all functions. Here, the main function with respect to a fuselage would be to carry my payload. Good. Very good. Next.
Sir, for tail plane, it consists of elevator and rudder, which helps aircraft for pitch up and pitch down motion.
So the
And
tail plane, okay, relax. Relax. It's okay. Okay. So we have fuselage. We already know so far. We'll give it a main function of payload and crew and everything else. Now we have tail plane. Okay. Understand, I've already told you all the main function of tail plane. Predit, you are giving me function of primary controls. No, you're talking about tail plane. Tail plane function is stability. Remember, it's designed to give aircraft inbuilt stability. We have to be very specific with respect to what kind of question is being asked. So here the function of tailplane is simple. It is stability. Is that clear, Prerit? Simple. You would have come to that, but tailplane is stability, students. Okay. Next, what do we have? Who will tell me?
So, so we have the main plane. The basic principle of the main plane it will provide a lift to the aircraft, and it has the primary uh, controls and secondary controls as well. The primary controls we have the ailerons, and the secondary controls we have these slats, flaps, and spoilers.
So main planes are the wing of the aircraft. My main plane gives me what? It gives me lift. The main function of my main plane is lift. Okay. Next.
So the vertical stabilizer, which houses the rudder, gives us directional stability.
Mm, okay. So I would be including Jason's and Prerit's answer to this. I have primary control surfaces, and I'll put, yeah, okay. I have primary control surfaces, which is my rudder, which is my elevator, and which is my aileron. These primary control surfaces are going to give me, now Prerit, your answer comes, control of the aircraft or maneuverability of the aircraft, control to change direction of aircraft in simple terms. Now we are talking about aerodynamics. See, the language will not change, the keywords will not change, the context will change. The context with respect to how we are looking at the aircraft. Okay. That's why the segments are made for us to understand the main functions of these aircraft again, because aerodynamics needs to be learned with respect to lift. Main plane's function is lift force generation. All our aerodynamics is first related to generating lift, but then that's not the only part. What is aerodynamics? We'll be coming to that. So my primary control surfaces, okay? My primary control surfaces are going to give me directional control. I can say are going to give me maneuverability, I can say, or in simple words, to change the direction of aircraft. So I have four important elements that I've discussed right now. I have fuselage, I have main plane, I have tail plane, and then what I have is primary controls. And what will we add in primary controls for a modern jetliner? Roll spoilers. Don't forget that, okay, students? The fifth important part, who can tell me? Om, Harsh, you're quiet.
Uh, I think, sir, landing gear.
The fifth, correction, not the fourth. The fifth important part would not be the landing gear. It would be the power plant. Okay. Simple. It's a very big engine for this aircraft in proportion. What is it, students? It's the engine. Why do we need the engine? We need engine to develop a force called thrust, or we need the engine in simple words for the aircraft to go straight. So I'll put my engine somewhere here. So this becomes my fifth main part of my aircraft with respect to aerodynamics. Engine or power plant. Engine to move the aircraft forward. In simple words. And we do it by generating a force called thrust. So these, now my final thing I can add is a landing gear. We know the purpose of landing gear, or we'll be doing landing gear in our next segments ahead. So these are my important aspects of my aircraft. Good job, everyone. Somewhere or the other, you are right. Tailplane stability, primary control surfaces for maneuverability and control. Although with respect to airframe, we know they have to give us a sense of balance, sense of stability also. So be very careful with respect to how the question is being asked to you. Look at the options and you'll know only the correct one is. Don't assume any options before you go through any options in the question, students. You might think something wrong and then the something wrong will be marked. First understand the question and then go ahead with it. Now that my aircraft, I know, has these important functions, I need to also understand why is there a difference in different kind of aircrafts. I have seen aircrafts which are, let's say, what is this orientation called for a wing with respect to an aircraft?
Cantilever.
Cantilever.
Cantilever. Very good. Then I have what? I have this.
East cantilever.
What is this called? Students, what
Braced
is?
monoplane.
Braced monoplane, sir.
Sorry, say again.
Braced monoplane.
Braced
Braced
monoplane.
monoplane. Yes. I have one more. These three I've seen, right? What kind of aircraft is this?
Biplane.
Biplane.
Students, what are the other configurations that you have seen in an aircraft? Think about it. I've seen a plane, okay, where the tailplane is above and engines are behind. What about you? What have you seen? Different configurations. One by one. Quick. Think.
Sir, I think the MD-11 or MD-80, I don't know. They have,
Describe the plane.
sir,
Yes.
they have conventional empennage section, but they have engine on below the vertical stabilizer.
Okay, so we have an aircraft where the engine is somewhere here, and then I have the stabilizer, right? And where's the tailplane in this aircraft?
Below the vertical stabilizers.
Maybe this is our tailplane. Okay. Only one engine here?
Negative, sir. There are three engines, two on wings.
Two on wings. Okay. Like this. All right. What else? Come on, students, input. Think. Have you seen any other kind of airplanes? If yes, how do they look like? Describe. I've seen another airplane which is having stabilizers like this, like, and maybe engines are here, I guess, or maybe engines are somewhere here in the wing, maybe in the center, similar to our Concorde. I've seen fighter jets, okay,
So
with
there are some
vertical stabilizers
aircrafts
like this.
which have
Mhm.
like wing configurations different levels. Like you have mid wing and you have the wings above the fuselage. Some wings have
Yes,
below the
I have
fuselage.
aircrafts with respect to wing, mid wing, high wing, the cantilever that we have seen, correct? We have then triplanes, we have biplanes. Very good. Why do you think we have these different kind of aircrafts with different kind of design? Is it for style purpose? Is it for looks?
For
What we
maneuverability.
understand for maneuverability, okay. What else? Muskan, what do you think?
For better aerodynamic functions.
For better aerodynamic functions, Prerit, Nukul, everyone. Students
Stability.
taking this class later on, you have to think about it too and give me answers on WhatsApp. Yeah. Stability, okay.
So for speed purpose,
For speed, okay. So, with respect to what my requirement is my requirement stability mainly? Is my requirement speed? Is my requirement to carry cargo and payload? Is my requirement to take off and land vertically? Is it to take off and land short? Have a short STOL, we call it short takeoff and landing. Is my requirement to operate in bad weather? Is my requirement to have turboprop engines, turbojet engines? With respect to operation, with respect to the business perspective, where will the aircraft be used in service? Different designs are made. Now, if I want to be an operator, I'll say, okay, I need an airline. I need an airline to connect all remote villages. That I know for me, ATR could be the best choice because I won't get any other aircraft that light, that small, uh, with respect to giving me such huge passenger seating capacity. And ATR or Embraer or anything else that I'll find. So I'll talk to the manufacturers, I'll take quotation, I'll see whether they have aircrafts in service or whether they'll be manufacturing those aircrafts for me. If yes, how much time will it take? Or can they modify their existing aircraft for me to give me my purpose, to fulfill my purpose? If I want to do water landings, seaplanes, then I need high wing aircrafts and I'll need the landing gear systems to be float type. And if I'm going to go into a desert area or some other area, then again, high wing will be there. If I'm going to have a purpose from city to city, cargo and passenger, then my basic cantilever aircraft, which is very, the wing is very close to the ground, is good enough for me. Like your 737 NGs and all, they are very close to the ground, very close to the ground. Why? It's an aircraft. Why is it so close to the ground? It's not a race car. Then we see one of the engines, the it's not completely circular. It's like this, so that it doesn't touch the ground. But one of the best aircrafts, like one of the best aircrafts of its time was 77 NG next generation. So basically, understanding of my flight dynamics gives me the ability to refine my mechanics of air or mechanics of motion of my airplane in air to serve different purposes. But all these aircrafts will have certain common elements, and these are those common elements that we see. Okay. And these common elements will be there in all aircrafts. And what will make the another common element exist in your understanding of all types of aircraft is the laws of motion that your aircraft will abide by, the theory, the principles, the formulas, and the coefficients, and the basics of control, and the basics of maneuverability, and the basics of stability. We won't say they are basics. We will say that they are the supporting columns. They are the most important part that we have. So, in order to understand what is happening exactly in a subject called Principles of Flight. What are these principles? Basically, here we learn in Principles of Flight, what we are actually learning is physical properties of air. Air. Students who have started meteorology, you must have mastered air by now. What is air? You need to know. The property of air changes with altitude. You need to know. The property of air pressure, velocity, high pressure to low pressure to high pressure, difference difference in pressure. Everything is important for us to understand aerodynamics. Why? Because we are flying in air, and air is what is giving us support in air to fly. So we come back. We come back to our basic understanding of why am I learning principles of flight. So I tell myself that, okay, this is my ground and this is my aircraft on ground. Okay. I don't know why it's all white. And this aircraft has a force. Here you will be introduced couple of forces with respect to Newton's law of motion. There'll be a lot of questions connecting Newton's law of motion and your basic generation of one of the primary forces or secondary, one of the primary forces, of course. Lift is not a, I won't say it's a direct force. Is it a resultant force? These little words, little principles are very important for us to understand the whole dynamics of aircraft moving in air. So we talk about how to get up in air and what is this law of motion. There is one law of Newton's, there is one Newton's law of motion that states that any object at rest or any object in motion. So we'll keep the motion part up aside. We'll say any object in air, correction, any object at rest continues to stay at rest until it is acted upon by an equal or external force to disturb it or to move it from its rest position. The moment the force, external force applied to this body at rest is equal to its force which is keeping it at rest, then we say there is an equilibrium existing. Okay. So in order to make this aircraft go up, I will need to abide by this law of Newton's law of motion. One, two, three, however you want to call it. There are statements that we'll be looking at. My aircraft on ground will be on ground till the time it's acted upon by an external force. Now let's talk about an aircraft in motion. An aircraft in motion will stay in motion until it's acted upon by an external force. So, what does it mean? It will go on and on and on and on and on till the time I give it some external force to make it stop. What kind of force am I using? You will say, sir, during landing, I have spoilers. I can reduce the thrust. I can use, of course, my lift dumping devices or something or the other where I can increase the drag. All these basic things that will obviously come to our mind with respect to any external force being applied on the aircraft. Now that there is another law of motion and then there's another law of motion. One will be of gravity, one will be of force is equal to mass into acceleration and all those things. But how does this aircraft fly up? Can we directly have a forklift and lift it up? No. Can we have somebody push it up from below, a human or a machine? No. Are we using a catapult sort of a device? Not really. What are we using then? How are we getting it? So we need to understand the beginning of everything. And the beginning would be a force called weight acts on an aircraft when it is on ground, and the unit of weight is newtons. What we call kg as a unit is a unit for mass. Mass is the amount of matter in a body. Mass into acceleration of gravity gives me a force, which is weight. So, my understanding of principles of flight begins with I understanding or my understanding of the first force acting on the aircraft when the aircraft is on ground, and which is weight. You need to clearly understand weight is equal to mass of aircraft into acceleration due gravity. Okay. Weight is in newtons. All right. This we get from a formula note force is equal to mass into acceleration. In simple, we write force is equal to mass into acceleration. Okay. Now, this understanding I want all my students to have as they go ahead. Please take your time, couple of minutes, and study it right now. What is mass? What is weight? What is force? What is the first force acting on the aircraft when it is on ground? Quickly soak it in. Principles of flight, property or physical properties of air, okay, and its reaction on aircraft to give best type of aircraft design for a particular operation. Now, this is something that might be asked in the exam, might not be asked in the exam. It's a very generic thing, but I want you all to have the clarity. Okay. Physical properties of air and its reaction on aircraft to give best type of aircraft design for particular operation. For us, an understanding of all these concepts is highly important. And it is very easy and very interesting. So my aircraft on ground is acted upon weight. The unit is Newton. Weight is mass into acceleration because weight is a force. The first force, force of weight. तो जो भी हम लोग weighing scale पे whatever we measure on our weighing scales, our personal weight, generally that is in kilograms. So whatever conversion the weighing scale does, it converts force into mass by accounting for acceleration. So it measures force, acceleration of gravity, and it gives you resultant mass in kilograms. I don't know if you all knew it before or not, but now is the time you remember, sorry, you understand, realize, soak it in, then ensure you remember. Okay? I want you all to be that kind of an aviator, student aviator now, and a professional aviator very soon, who knows these values by the way it's supposed to be known. We need accuracy in our information, nothing else. Do we need it? Do we not need it? That is a very silly question. If it's there in our books, we need to know it. Simple, whether you give technical or not, whether you give any exam or not. You are an aviator, you need to know these things by the word that they are, and not what you think they are or what not what people think they are, but what they actually are. That takes me back to one doubt that one of our students had shared today, talking about magnetism. So he's doing nav also on the side, and I just asked, how do you feel about magnetism? He said quickly the first thing that I was always worried about because I've seen textbooks in school. He said, sir, कुछ उल्टा ही पता था पहले मुझे and कुछ उल्टा ही समझने पे मजबूर हो गए थे बट अब अब सीख रहे हैं तो समझ आ रहा है. Students, it's not your fault. I have seen it. I have seen it in what eighth or ninth books also on magnetism. And there is a big statement given to prove what people think is right. And that actually doesn't make sense. And people are giving board exams on basis of that knowledge. So yeah, we need to learn these if we are in aviation and not discount these things. Simple. Otherwise, somewhere or the other, we'll end up acting like people who don't know much, and then our opportunities can be missed, which I don't want anyone to go through. So, force, mass into acceleration. Jason, would you want to talk about this little person you have here?
Yes, I shared that image, when we were talking about different types of
What do you
configurations.
call this aircraft?
This is Antonov AN-72,
Hmm.
and the basically build is designed because it was mostly to operate in Antarctic regions, and they had this engine design because they didn't want ice getting into the turbines.
Mm-hmm.
So
So they wanted it for Antarctica, okay. But what's the main purpose of this aircraft? Is it like what do we say? Payload?
mostly cargo, sir.
Cargo. Correct, correct, correct. See, we have to think about with respect to its main purpose and then the characteristics for that particular place. So very good. I'm just sharing this picture with everyone. Where is it? Okay, one second. Stand by. What's wrong? Everything is being opened in Paint. I'll just open with photos. Please go on mute, students, if you're not speaking. आप लोग को PTT simulate करना है, students. Push to talk. Hmm. Okay. See, look at this aircraft, students. Can everybody see it? We have a cantilever type of plane, but it's high top wing, like high wing. Okay. We have engines mounted forward. And look at the engines, magnificent engines, so big, almost like 1/4, I would say, or 1/8 of the fuselage size. And then look at the tail. Look at where high tail. Why? Because the tail should not be obviously disturbed by the exhaust of this. We need the plane to have normal airflow, the tail plane to have normal airflow. Interesting aircraft, see? बहुत अच्छी aircraft. And the main purpose, of course, as Jason is saying, to avoid any ice intake. Simple. So as high as you could put. Now somebody on the other hand could have thought, why put the engine here? Put the engine back. Put it as high as you could. But it would not fit the entire dynamics that we would need. So this is the best configuration, basically, for this particular aircraft. Otherwise, Antonovs we see come into multiple engines also. And they're one of the best aircrafts for cargo, military defense, everybody uses it. Good. Anybody wants to share their ideas on this? And puts inputs anything, Jason?
Negative, sir. That's it, sir.
Hmm. Good, good, good. Students, if you come across anything interesting like this in the course of your training, especially principles of flight and everything, you will share it with me and let's discuss. Let's keep discussing. Let's keep talking aviation. Students, that is the greatest thing, you know. So now my aircraft firstly has this weight and I need to counteract this weight to fly up. Okay, simple. So my law of equilibrium of motion, whatever it will be addressing it when I give you notes. That says that my ground, the force acting on the ground, the weight, it must be balanced by a force. Balanced how? We need to check the direction also. Weight at any given point in time acts vertically downwards. Please make a note of these points. Everything that I'm saying is important. You don't have to now take everything dictated by me. Okay. Now we are going to increase the pace of our learning as we have discussed. You'll make your notes, then you'll have text to read. Simple. We'll never forget that exercise. In between, don't expect me to write everything. If you have understood something and if you think you'll forget it, make a note of it. And students, towards the end of the session, in real time, you can always ask for PDF also to selected students only. So my weight always acts vertically downwards at all time. And that is true even when my aircraft is in air, I can say. Okay. So my weight, okay, acts vertically downwards at all time. Now, in order to make my aircraft fly, I need a force that is equal and opposite to weight. Equal and opposite. If anybody will argue saying that agar equal hai, if it is equal, then how will you fly up? You said this is how the law of motion is. We need equilibrium, nothing else. There's a classic example that goes in every mechanics of flight textbook, which is there's a book on a table. The book is on the table. If you want to lift the book, you need to produce an equal and opposite force, the force that this table or the book is facing when the book is on the table. The force that I'm doing to lift up with my hand could be more or less, but the minimum force I require is equal. If I increase the force that the book has right now on the table, then the table can break also. So we have to understand in order to counteract any force, the opposite force is always equal and opposite. So if you want to stop an aircraft, if this is thrust, you give equal and opposite force, that is drag. You give equal drag. Drag equal to thrust. Lift and drag, thrust and drag. They both will have uh, relationships with each other with respect to how they play out and how the aircraft design is, when there should be minimum drag, more thrust, or however it is. Drag is also taught to you in some detail with respect to your mechanics of flight. So my weight acts vertically downwards at all times. Weight is a force, mass into acceleration, that is mass of the aircraft into acceleration due to gravity. It will always act like this. The weight is said to be acted through the CG of the aircraft. Okay. Now, in order to make my aircraft fly, I need a force which is equal and opposite. Now that I know equal and opposite, it should be something like this. And as we all know, this is my lift. Okay. You will write lift has to be increased the moment you start rolling the aircraft on ground for takeoff. What is actually happening is you're generating lift. You start increasing lift. You don't instantly get lift. You start developing lift, but it's not enough. It's not enough. It's not enough. It's not enough. You start and you start increasing till the time it is equal to the aircraft's weight or it is same as the aeroplane's weight. Not more, not less. Such MCQs you should not be stumped whatsoever. Okay, students? So lift has to be increased in order to fly, increased until lift is as same as aeroplane's weight. I I think I should already obviously make it obvious to students about the lecture strategy and study strategy. A gentle reminder to everyone taking the session. This is just not a lecture. You also study in this lecture. You study, you understand, you study right there instantly. Let's call it instant study. That is why the pause and that is why the gap and that is why everything else is involved. You don't think the pause is for anything else. It's for you to study and ask questions, report your doubts, park your doubts, share it across in real time. Okay. So that the next time you read the book, it's just like a thorough revision and some extra pointers to be read, and then final revision. There, 100%, 100%, 100%. No load in life other than the payload that we are going to lift up. Simple, right? Now, how do I get lift? That is a problem. I don't just get lift. In order to get lift, I need another force. And that's where my principles of flight, flight dynamics, physical property of air, movement of what we know airfoil, through the air comes into picture. Aircraft didn't always fly with an airfoil cross-sectional main planes. They still flew. So there's another flight dynamics which is similar to the one. It's there. It's just a thin sheet of main plane flying through air. I'm missing one of my greatest books. It was called Flight. Any student who think they have it, I might have given it to read. Please let me know and return it. I don't know whom I have given it to, and everybody's saying no, they don't have. That book has That's such a beautiful book. I had found it at a reseller in near Gateway, near CST, and it was many years ago. And I looked at it and I'm like, Why would anybody throw a book like that?" It was a little tone. It was big. It has real pictures from the Wright brothers and the real concept of how they discovered flight with respect to the biplane design and a cardboard that they were playing with. And that's how a cardboard box gave them the actual final idea where the Wright flyer was made. And the mechanics and everything we studied later on, it was different. And that flight was really very different. And they didn't have conventional controls. If you look at Wright Flyer, you will see a very unconventional design. We have made these planes conventional, but that plane, the main plane, the first plane that we see, is really very unconventional. Where you'll see stabilizers, I think, ahead and not behind. And the pilot was, I don't think, was sitting like this. The pilot was sitting like this to hold the aircraft like that, something or the other. Yeah. So anyway, so how do I get this lift? In order to generate lift, the aircraft has to be moved forward, or the word that we have is propelled. You don't generally need a propeller to propel. Jet engines will also only propel you ahead in basic terms of aerodynamics. Jet engine works on the principle of law of motion. Every action has an equal and opposite reaction. Okay. Propeller also will work with respect to the similar theory only. So I need a forward movement to propel the aircraft to generate thrust. And when I propel the aircraft, it's not like anything you move and you'll fly. If that was the case, my cars would fly, my bikes would fly, my cycles would fly. Me running, I would also fly. I need a proper cross-sectional main plane, which I have to move through the air forward or propel it along with the entire aircraft, of course. And then because of the dynamics of the air on the main planes and the dynamics of the air on the fuselage and tailplane, everything conclusively will ensure that I'm flying. Although the main planes are attributed to generate lift, all other design factors are designed in a way that the drag is minimized. So they also have to be studied and designed with respect to aerodynamics. Otherwise, my fuselage would not be a circular cross-sectional, because we know a circular cross-sectional fuselage will give us a lot of space wastage, right? So I need a forward force to propel the aircraft ahead to generate lift, and this is called thrust. To lift, aircraft needs to be propelled forward. Okay. And how? Forward through the air. Okay. Without air, we won't have all this. That's why we call it aerodynamics. Aero is for air. Aeroplane, a plane that main plane. Okay. Plane is not an airplane. Plane we know is just a simple plane structure. This is also a plane. To lift, aircraft needs to be propelled forward through the air. Okay. And it does so by a force called thrust. Understand the keywords. We all know this, but we have to understand it from the perspective of fundamentals or principles of flight. And this thrust is provided always by engines in a powered flight. Okay. Now we have resistance from thrust. The moment my aircraft starts moving, I start developing resistance. Resistance, as we know, is something that is opposing our forward moment. Resistance could be a lot of things with respect to philosophy also. Here, what is this resistance about? This resistance will start to be felt the moment the aircraft starts moving. Okay. From the moment the aircraft will start begin to move, air will resist the forward motion of the air. And the air resisting the forward movement of the air will generate force. It's a force. The resistance is a force, and that force is called drag. It's air giving resistance to the forward motion of my aircraft through a force or via a force that is called drag. And now I don't like this drag. It is not good for me. It has to be controlled, but it is good for me when I need to stop the aircraft or land the aircraft, or sometimes control the aircraft or lateral control maybe. See, so much we already understand about dynamics of an aircraft. So my drag. Drag doesn't exist when the aircraft is on ground. Okay. As soon as when the aircraft is on ground and at rest, as soon as aircraft begins to move, air gives resistance to the aircraft's forward motion with a force called drag. So weight acts first. Lift is required but will not act first or second. Thrust will act second. The moment thrust acts, drag will start third, and slowly lift will also be generated. So drag and lift, I could say, are third and fourth, or fourth and third, however my aircraft is designed. But the moment it starts, even when lift is zero, there will be drag. Lift will be the fourth force, which will come into action as a visible aspect of my flight taking off. Anybody telling you that, okay, my aircraft has taken off now, what is the relationship between lift and drag, lift and weight? Say they are equal. They are equal. I can always compare lift and thrust and say my lift has increased or thrust has decreased or thrust has increased, lift has increased, however the relationship is, and then drag. But my weight and my lift generally, unless we see it otherwise during our course of learning, will generally be in equilibrium. I can definitely at times try to increase my lift and my aircraft will go further up. So an external force will destroy the equilibrium. So my straight and level flight, a cruising flight, straight and level flight is always in equilibrium where all forces are sent to be somewhere or the other, not increasing, not decreasing, in a state of equilibrium. In order to increase my airspeed from a cruising altitude, increase the altitude or decrease the altitude, I'll have to impact the equilibrium by increasing or decreasing certain forces. And that's how I'll be further increasing the speed or decreasing the speed or going up a little or down a little. So in order to go up a little, I'll increase the angle of attack probably or increase the thrust if the thrust is not yet full. So I'm adding extra force. That extra force will disturb the state of equilibrium. This is the most important of Newton's laws of motions that will guide almost all of your theory of your aircraft in flight or your airfoil in flight or aerodynamics. We are not talking about engine. Engine is gas dynamics for us. There we see Newton's third law of motion there mainly. Lift generally is a resultant force that we'll see when we see the flow of air over an airfoil. So I want you all to go through your notes, soak everything in, and tell me if you have any questions. Yeah, Jason, Mechanics of Flight is a good book. Really good book. You should always keep it handy if you have it. But we should always study from our DGCA prescribed books first for CPL, and then we can take support from further reading, even though they are not given to us for CPL. Remember that. All of a sudden, you have learned about force mass into acceleration, force unit, weight unit, Newton, mass is in kg, mass into acceleration due to gravity will give me weight. Weight acts vertically downwards all the time. In order to make my aircraft fly, my lift has to be equal to weight and opposite. In order to get that lift, I have to move the aircraft forward, which is obtained by a force called thrust, which is generated by the engines. The moment the aircraft starts moving ahead, my aircraft gets resistance from the air via a force which is called drag. The moment my thrust is enough, my lift is enough. The moment my lift matches weight, I'll have liftoff. Think if you have any questions, doubts. Think if you are thinking about something and would want to share. Think, think, think. Yes, Jason, go ahead.
So we discussed that in case of power generated aircraft, thrust is generated by the power plant. What about gliders in that case?
Nothing. You need to drag the glider using, you need to basically tow the glider using a jeep or a car, or put the glider go downhill to generate that thrust, because we don't have engine. So in order to take off a glider, some people with light gliders can also pull a glider with a rope and then detach the rope also. It is very aerodynamic, so little bit of thrust also will give it, but it needs thrust. In air, glider changes. Glider needs some warm or dry air pockets where air is traveling from high to low, low to high, and we generate lift, lift, lift through those air pockets. But otherwise, we need drag in glider also, and we simulate the drag without engine. Simple. We need forward motion to generate lift, and that thrust, I said drag. We don't need drag. We need thrust. That thrust is obtained by forward motion only. Gliders don't have engines, so we need forward motion. Forward motion can be done by pulling through a jeep, car, vehicle, or people, or letting your glider go downhill and then take off like this.
Yes, sir, understood, sir.
See, this is a very good question. Even if glider doesn't have engine, it requires thrust. It requires forward motion. Otherwise, it will not fly. Simple. Think, 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 think. Students, if I have slip of tongue, correct me. Don't quote me there, okay? I mean, if you think it's okay, then it's fine. Otherwise, some people who are always there to try to create destruction in our lives, ओ सर थ्रस्ट को ड्रैग बोल दिए, उनको क्या ही आता है, अरे क्या बस क्या अभी, मतलब एक दिन घर में किसी ने नमक ज्यादा डाल दिया तो ऐसा हो जाए, ऐसे करोगे आप? मतलब आप में प्रॉब्लम है, चलो आप यहाँ मत आओ, जाओ, डोंट टॉक टू अस, सिंपल. So I want you all to understand what is the interrelationship between these forces. Okay? Simple. Greater the weight, greater the requirement of lift. Okay? Okay? Then we write greater the lift, what do you think will come? greater the drag. Then you will write greater the drag, greater the thrust required. Now, to supplement Jason's doubt, or the doubt we just had, gliders have the least amount of drag. That's why in least amount of thrust also they can take off. Now, this relationship is very important to understand the flow of forces which I was talking about earlier. I have to counteract weight, so I need more lift. In order to need more lift, I'll have more drag. Why? Because my main plane, my design, everything will be more, bigger, bigger, bigger. So my drag will be bigger. Not just because of weight, but because of the surface area of that particular place, particular structural member, I would say. And to counteract that drag and still move the aircraft forward, I need thrust. So now this is the relationship of your forces. And it will continue. The relationships will then continue. Please make a clear note of these things, students, because this is one time investment. Okay. We think we know everything, but do we know it from this perspective? Then no, then we do it. If yes, then we make sure that we are masters of. You mastering aerodynamics is like you mastering everything when it comes to theoretical knowledge also. And you'll always feel happy about yourself. No matter what anybody says, you'll know that you have mastered aerodynamics. And it's not that everybody can do it or knows it, how to do it. I want you all to have the same attitude in your flying school also when you're flying. What? Mastery of the art of flying. And your art of flying or your training will be divided into different segments of operation of your flight. So you will be mastering all segments. You don't be like other students worrying about fulfilling your hours and getting your CPL. You think about mastering each segment, each maneuver, each test. Feel the air on the wing, on your control column. Feel it in all variety of environments, all variety of daylights, all variety of weather components. Feel it with variety of weights. Feel it's all about the feel that you learn the handling of the aircraft with respect to how you are trained, how you are sensing the instruments, and if you're, how you are sensing the overall feel of your aircraft. You will feel the weight of air with the type of aircraft you're flying. You just enjoy that process. Be the master of your flight. People should know you. People should know you by name saying, इसके जैसा ट्रेन ही नहीं देगा कभी आज तक. Simple. Some of our students who are very, adventurous and who like to do stunts with respect to bike, car, and even if you sit with them, you're like, this could be the last day of your life. I've done that and I've stopped doing that traveling with my students because they will drive cars as if sometimes it's fine, but not every time. So I have heard their stories, they do that with your training aircrafts also. And although they came out successful and some people say, oh, you did that, it's not safe for us to do. Never do that. Never do that. Don't go beyond the blanket of your training modules or your training limitations. Never do that. Never ever do that. Don't do it. Simple. If your aircraft is designed for something like that, then you take proper training, practice, and only then you do it. So I remember this one of our students. He used to tell me, sir, we used to do this. We used to try to be as close to the water without any permission and then go up. They had this trend. Why would you do something like that? Do you know the formula for lift? Not really. Don't do that. One high wave would have also caused him drag on a plane like that, but he came out happily. But every year we see some of these stories, somebody's friend, somebody is not there anymore. And I'm like, I don't want to hear about it. But you have to have this attitude that you're going to master. That's why you'll see anytime anybody is referring anyone with aviation, they'll always say masters of air, mastery. It's all about that one word, master. It is it is not based on gender. Okay. Anyone can be a master if you're good. So, note important notes for us to remember. Properties of air vary with altitude. So, this, along with these forces and all these variables, makes it very important for any student to ensure that these concepts are thoroughly clear in my mind in order to have a complete understanding of principles of life. And it's not difficult. You just need to be focused, focus in class, study in class. Don't just learn, study, and then ask questions. That's it. Now understand my aircraft design is a design of compromise. If I'm increasing the wing surface, lift coefficient, like see, I'll show this to you. So my lift formula, as we already know, okay. So if I'm increasing the surface area, okay, if I just say that I want to increase the surface area of the wing, I will also be increasing drag. That's why it's compromise. Okay, what increase in my surface area will give me the least increase in drag? Something like that will always come in your ideas, your understanding basically. So I'll just give you a heads up with respect to what do we say? A formula, okay? Just make a note of it below this formula. See if you have any questions in the meantime, students. I'll explain everything to you all as we go ahead with respect to what is your half rho v square and everything. Luckily for you, you don't have to do a high level of numericals. There will be only limited numericals for you, very limited. I would just want you all to focus in class and ask questions. That's it, okay? Look at the similarity between the two formulas. Everything is same, just the lift coefficient and drag coefficient is changed because of the value. Everything else is same. This rho in both places is air density. You need to master air density and the impact of density with altitude. And air density is something that will give us pressure difference between the upper surface of an airfoil and lower surface of airfoil because of the velocity of the airfoil, upper surface and lower surface not being the same. The camber, more the camber, it will increase the velocity, reduce the pressure. Below the surface of the airfoil, high pressure will exist, and air has a tendency to move from high pressure to low pressure. This high to low movement from below surface of the airfoil to the upper surface of the airfoil gives us the lift moment or lift force that either pushes or pulls with respect to however you want to see it, lifts the air in Lifts the aircraft in air. To develop this fluency into explanation of this complex topic, you need understanding and revision. Understanding, focus, and study in class. Revision, read, ask questions. Don't assume. Any questions? So key players here are shape of the airfoil. Okay. Then I'll tell you the plan area of the airfoil. Okay. Square of the velocity and density of air. Air density. Simple question. Is my air denser on ground level compared to 10,000 feet above? What do you think? Where will be air more dense? At a ground level or sea level, or at an altitude of 10,000 feet above ground level?
On
Sir,
ground.
sir, on ground, on sea level, density will be more.
Very good. Hmm. Simple, right? Why? Can anyone tell why?
At the lower altitude, there will be a temperature is high as compared to high altitude.
Temperature relationship secondary. Good thinking, Nukul. It's secondary. Majority of the atmosphere is on the surface of the earth. Simple. Pressure is more. Pressure density. टेम्परेचर नहीं बोल सकते ना जरूरी थोड़ी है ग्राउंड सरफेस पे हमेशा हाई टेम्परेचर होगा व्हाट इफ देयर इज बिलो 0 डिग्री टेम्परेचर ऑन ग्राउंड सरफेस दैट इज पॉसिबल राइट the effect of temperature on air in altitude is not that bigger in comparison to the density fall or pressure temperature fall or pressure fall with altitude. Remember this point from meteorology students. The effect of temperature. Don't worry. The thinking is in the right direction. Don't worry. See, I'll show you one thing. This is a box. Okay. So in order for me to check the drag in this box on this box, okay, I will see its frontal area. How much of the front of this particular box is meeting my air? That will show me drag like this. So my hand, my palm right now will give me frontal area for drag. But the moment it changes the shape or I change the shape to an airfoil, okay, my drag is with respect to plan area, complete plan area, not the frontal area. Okay? Remember this. These are little tiny bits of things which will improve your understanding of everything that we are going to do. And you are so smart. Okay? You are so smart. That's why here, okay, add this plan area here now. That's why I was waiting to add plan here. Plane area, plan area. We call it plan area only. Yeah, you are so good students with the way you are going ahead with tech right now that you don't even know, but a part of your aerodynamics syllabus you have already done in flight controls, which is control of the aircraft, a part of it. Anybody who's ever thinking, अरे sir कैसे पढ़ा रहे हैं lecture lengthy है छोटे है, understand? You go with the flow, have belief, study what you are being taught. Don't worry about anything else. It's all like jigsaw puzzles, but each puzzle in itself is self-contained nicely. And there'll come a time that you will have that eureka moment, sometimes sooner, sometimes later. But with me, if you go ahead at the pace, you will see all of a sudden the whole picture will be formed and you'll see, okay, Okay, I should do what sir is saying because I'm there. I'm there sooner than I thought I'll be there. Everybody who's tried and tested the strategies, you all know it. So always remember that, okay? I don't want you all to be demotivated thinking, oh, what is happening? There's no PPT, why there's not list topic? You won't even know, and 10 to 15 points of your syllabus we might have already covered by now. I'm just saying that, okay? So you just learn and ask questions and study. That's it. Any questions? Good to go with drag formula also? Hmm? We will see what are the lift coefficients and drag coefficients when we get into coefficients. But you already know coefficients. We'll see what are they in specifics when we come to the right time. Quick, quick, quick. Do we have any questions? Nothing? Okay. So before we go to the next session for principles of flight, which will be our next lecture, today after lunch break, you will be going through your textbook, which I'll be sharing notes during the break. And 2 to 3, you will give that text a read. All pages that I'm including. Students who are doing this session later on, like on your own time, like most of y'all will be doing, you are required to request for access of these notes as soon as you finish L13, and then you'll report completion as a continuation of this lecture itself after the lunch break. Are the instructions clear, students? Once you have learned all those 2 points, I'll be quickly teaching you and telling you about those points in next session. That is whenever it is going to be when you take it. For us, it's 12, same time, live students. And we'll quickly start and have the first hour done for these little elements so that we can start with our airflow, two-dimensional airflow, and what is the difference between subsonic dynamics and transonic dynamics. We'll understand the difference also. And our airflow will be dividing, subdividing with respect to that structure. You have to be very specific with respect to your basics. So the same strategy would be followed to attend the lecture, ask doubts, go through your notes, go through your reading text as given. There are no other homeworks apart from completion of the task. 2 to 3 will be your time. So anybody who's doing this session, another hour, half an hour, how much ever it takes. Students finishing the task in 30 minutes, give 30 more minutes to study. If you are 200% thorough that whatever I have read, I know, then only you will leave it early. Otherwise, till 3, you are going to study or give another hour. There'll be symbols, different symbols. Okay. There will be definitions, which are very important. A lot of definitions. Don't memorize, just read. And there will be certain laws and definition of laws. Newton's law. What is acceleration? What is mass? And everything. I would want you all to just keep it read. And while reading, if you have any doubts, send me a screenshot. Are the instructions clear, students?
Sir.
How are we feeling? Feeling good? कोई बोलेगा मुझे वर्बली जाने से पहले एक एक बच्चा बोल के निकल सकता है क्लास से मुस्कान आप स्टार्ट करो so how you feeling getting on with aerodynamics and so far give me a 10-second report Muskan you'll start and feel free to leave then one by one we'll take it from everyone and we'll leave
Okay, sir, I feel good about the aerodynamics, and what I learned today, what I studied today, is I understood everything. I have no doubts now. But sir, I have one question.
mm-hmm.
It is related to lecture 1.1. So
Mm-hmm.
what kind of questions can be asked on different type of flaps? Will there be diagrams or angle of attack percentage or value something?
A diagram can very well come for you to spot what kind of flap it is and then increase in percentage of increase in angle of attack for basic airfoil and increase in maximum lift and then the 4 points that we have added. So what you need to study mainly is double slotted Fowler flap and basic airfoil and the one, what was that? Camber flap. What was that? Which we use in light aircraft. Those
Plain
three are
flap or
very
flap?
Plain
sorry,
flap.
plain flap, yes. Those you will master, and slow and steady, then one by one flap you can master as you go ahead. You can keep yourself a task that okay, every another day I'll master one flap value, one flap. But these three you'll master first. And single slotted Fowler flap is also good wherever we get variable camber, including the increase in wing surface. And a difference between slat and the other flap where we don't have slot can be asked to you in simple words. बाकी तो ऑक्सफोर्ड में तो सारे फ्लैप्स है भी नहीं जो हमने लास्ट में ऐड किए हैं दो तीन, तो वो तो डेफिनेटली आएंगे जो हमने ऐड किए हैं, समझ रहे हैं आप लोग? सो या, नॉट जस्ट ऑक्सफोर्ड, लाइक मोस्ट ऑफ द बुक्स आई थिंक दे मिस्ड इट, और आई डोंट नो व्हाई दे डिडंट गिव इट. ओके मुस्कान, यू कैन लीव. हर्ष आप बताओ. मुस्कान आपको क्वेश्चन रहेगा
सर
तो पूछना है, ठीक है?
यस सर, आई फील गुड अबाउट एरोडायनेमिक्स। मेरे को इंटररिलेशन भी समझ में आया लिफ्ट वेज ड्रैग और थ्रस्ट का। सर मेरे को एक क्वेश्चन ये है कि सर जैसे हमने यहाँ पे पढ़ा कि लिफ्ट के लिए हमको आगे की तरफ प्रोपल्शन चाहिए, मतलब
हम्म.
हम आगे की तरफ प्रोपेल करेंगे, फिर एक स्टेट ऑफ इक्विलिब्रियम आएगा जहाँ पे लिफ्ट और वेट इक्वल होगा, तब हमको लिफ्ट मिल जाएगी। सर मैंने एक एयरक्राफ्ट देखा है दैट इज F-35, करेक्ट,
हम्म.
F-35। सर वो
हम्म.
एयरक्राफ्ट लाइक डायरेक्टली वर्टिकल टेक ऑफ और लैंड कर सकता है।
हम्म.
तो सर मतलब ये थोड़ा सा कॉन्ट्राडिक्ट कर रहा था सोचने में।
ये कॉन्ट्राडिक्ट नहीं कर रहा है बिकॉज वो रोटर यूज करता है. रोटर की जो ब्लेड्स होती हैं वो गोल गोल घूम घूम के एक रोटेशन स्पीड में आती है जहाँ पे वो अपने आप में एक लिफ्ट प्रोड्यूस करती हैं जो अपवर्ड डायरेक्टेड होता है. रोटर ब्लेड जिस एंगल ऑफ अटैक या इंसिडेंट से गोल गोल घूमता है वहां से हमें अपवर्ड लिफ्ट मिलती है. सिंपल. वो इंजन्स ऐसे बनाई होती है जो ऐसे भी जा सकती हैं और ऐसे भी जा सकती है. ऐसे जाएगी तो आपको फॉरवर्ड थ्रस्ट देगी, और ऐसे जाएगी तो आपको इनको वर्टिकल टेक ऑफ एंड लैंडिंग एयरक्राफ्ट बोलते हैं. उनमें भी लिफ्ट होती है बट उनमें रोटर एरोडायनेमिक्स आते हैं. रोटर जहाँ वर्ड आ गया वहां पे आपको वर्टिकल टेक ऑफ मिलता है, जस्ट लाइक योर हेलीकॉप्टर. बट हेलीकॉप्टर में एक रोटर होता है और पीछे एंटी टॉक टॉक के लिए कुछ होता है. यहाँ पे वो टॉक वॉक मेजरमेंट अपने आप हो जाता है बिकॉज आपके पास दो इंजन होती है. वो दोनों एक दूसरे को काउंटरडिक्ट करके जीरो टॉक प्रोड्यूस करके हमें ऊपर ले जाती है. सो ये कॉन्ट्राडिक्ट नहीं कर रहा है. मैंने बताया आप लोग को, ये वर्टिकल टेक ऑफ का डिजाइन है. वर्टिकल टेक ऑफ भी सेम एरोडायनेमिक्स यूज करता है ऑन दी रोटर ब्लेड्स. नेवर फॉरगेट दैट. बाकी सारा कॉन्सेप्ट सेम होता है.
ओके।
आप फोटो शेयर कर सकते हो. हर समझ आया ना आपको?
हाँ सर।
गुड क्वेश्चन, वेरी गुड क्वेश्चन. कॉन्ट्राडिक्ट तो कर ही रहा है ऑफ कोर्स, बट जब वीटीओएल करेंगे तो वीटीओएल इसका एडवांस हो जाता है. ऐसे वीटीओएल इज डिफरेंट देन हेलीकॉप्टर, वी कैन से इन सम एस्पेक्ट्स. We have one of our other students who is an army pilot and he is a very big professional, and he's already obviously flying also helicopters for army. And last monsoon they have done a lot of rescue missions. If we have a good fortune, a dynamics ke time, I'll see if he's free to grace us with his presence. So they'll be switching to commercial, so they're prepping on the side. They're also doing job. So yeah, वो हेलीकॉप्टर के बारे में फील बताएंगे आप लोग को. फील, one of the difficult things to fly for me is helicopter. So yeah, a successful helicopter pilot, hats off. Like कहीं भी ले जाते हैं वो, कहीं भी जाते हैं वो लोग. जहाँ लैंड नहीं कर सकते वहां भी जाके लोगों को बचा लेता है. चलो, good Harsh, you can leave if you're done with your question. You can wait also. Prerit, Nukul, Jason, one by one, quick. How do you feel? Quick report. Any questions? And Om, you also. And students taking this session, go through these Q&As before you wrap up the session, please. Yeah, Nukul.
So I feel good about this topic, and it's really help for to understand this topic because of the previous topic was very good for me, and I understood everything about this topic also.
कुछ की पॉइंट्स बताओ.
So the first key point is about the weight of the aircraft. Newton's law जो जिस तरह से apply हो रहा है वहाँ पे. And then other is the lift has to be increased in order to fly, increased until lift has the same as aeroplane weight. And it's opposite also. I think this point should be added on this.
Equal and opposite. Perfect. Very good.
Equal. Yes, sir.
Any
Is it?
questions?
No, sir.
Very
Negative.
nice. Very nice. Prerit, Jason, Om, quick.
Uh,
Nukul, you
so
can stay,
sir,
listen. Hmm.
yeah, sir. So feeling good about aerodynamics, and sir, many a times in past you have uh, told us about this weight lift drag, this force movement. So it is good starting with this basic, which I was knowing about somewhere. So feeling confident about aerodynamics, I had, sir.
Very good. Give me a couple of key points.
Sir, like the weight is the first force which is applied on the aircraft throughout the time, and then for for which we have to apply equal and opposite force to get lift, and we get lift from the force called thrust, and as we get thrust, we also get drag.
Very good. Very good. Very nice. Any questions?
Negative questions for now, sir.
Very good. Hmm. Om, Jason, quick.
Yes, sir. Yes, sir. I'm understanding the aerodynamics, the principle of flights, and I don't have any doubts so far.
Give me a couple of key points. And how do you feel?
Yes, sir. I'm feeling good, and key points are aircraft weight, and the one line is just a boomerang in my head is lift is resultant force. Uh, this uh, this was new, I think, and
आएगा आएगा उस पर हम बहुत रिसर्च करेंगे. अच्छा आपने दिमाग में बैठा लिया वो चीज.
yes, sir.
Hmm.
And the relationship between lift, weight, drag, and thrust, and their relations.
Very nice. Good job. थोड़ा दोबारा बुलवाया है बट सही बोल रहे. नेक्स्ट टाइम अपने आप से इतना बोलना है. आप थोड़ा इंट्रोडक्शन करके छोड़ देते हो, आदत अच्छी नहीं लगती मुझे. सोचने का सर ने वापस बोला और उसी टाइम पे ज्यादा बोल देना है. समझ रहे हो? क्योंकि हमें पार्ट 2 वाइवा भी करना है आगे जाके.
Affirm, sir.
वेरी गुड. जेसन.
Yes, sir. So aerodynamics so far so good, and it's been interesting, especially today when we discuss the formula, the difference between lift and drag. The only difference was that coefficient of lift and coefficient of drag. I didn't know that there was a formula for drag, so learned that as well today, and also that point where lift is generated when there's equal or opposite force. I didn't know that even equal force could generate lift. I thought it was always more
More.
force required to
This is
lift
the
it up.
paradox I talk about. Sorry to interrupt, but this is the paradox of a general logic compared to
Hmm.
aviation logic. We think अरे ज्यादा करेंगे तो ही आगे बढ़ेंगे, बट नो. ये लॉ ऑफ मोशन है, पूरा फिजिक्स में ये मैटर करता है, सिर्फ यहाँ पे नहीं, सब जगह पे मैटर करता है. आपको अगर एक इंजन एक एक ट्रेन को भी मूव करना है ना, तो आपको इक्वल फोर्स जनरेट करनी पड़ेगी, जो भी उसका वेट और ड्रैग का रेजिस्टेंस होगा, वहां पे रिलेशनशिप होगा. कैरी ऑन. कैरी ऑन.
Yes, sir. And also I was wondering like how we have this relationship where lift is equal to drag. Is there any relationship between thrust and drag? No, sorry, lift and weight. And is there anything like thrust is equal to drag in any case?
Yeah, we'll see. I told you, lift drag, lift weight, thrust drag, thrust lift. They all will have certain relationships. Definitely,
Okay,
we'll see. Be on the lookout for this as we go ahead.
yes, sir. Okay, sir. Apart from that, no doubt, sir.
Chalo, good job, students. Keep it up. You all know the time for the next session. Students doing it at their own pace. You'll be letting me know when you're doing it. Make sure you're done the reading task after this session, after your break, and then only you'll be requesting for access for the other lecture. Students, don't waste time. Do the needful, and then go ahead with the other task. Keep your proactive updates. It's a Monday. Make sure you don't need another reminder. प्रेरित, नुकुल, जेसन, ओम, मेरे को सबके अपडेट्स चाहिए. आगे के क्या प्लान्स हैं, क्या टास्क हैं, कौन से लेक्चर पे है, क्या चल रहा है, क्या नहीं चल रहा है. जो जहाँ पे जैसे है वैसे मुझे देने वाले हैं अपडेट्स. स्टूडेंट्स, taking these sessions at their own pace, same applies to you. You'll be giving me a reminder today anyhow. Okay, students, I'll see you when I see you. Let's do it. Let's learn more about air and let's become one step closer to our mastery of understanding air and flight dynamics. I'll see you in the next class, students. Take care.